Hello student, my name is Padve Deepmala Arun, Department of Chemistry, RBNB College, Srirampur, District, Ahmednagar. Today we are going to start 11th standard Science Chemistry subject, in which the chapter number is 7th is the elements of group 13, 14 and 15. In this chapter we are going to discuss or study in this chapter is allotropes of carbon. Allotropes of carbons means the carbon-carbon compounds are formed. In this allotropy, the 5 carbon compounds are formed. The first one is a diamond, second one is a graphite, third one is a fluorine, fourth one is a carbon nanotubes, and fifth one is a graphene. Means 5 allotropes of a carbon compound. Now these are the very important allotropy of the carbon and most useful allotropies of the carbon. The first one is a diamond, fluorine, graphite, carbon nanotube and graphene. One by one we will discussing in this lecture. Now the first allotropy of the carbon is diamond. We know that diamond, we also seen in a diamond we also seen in diamond. Now in that diamond, it's a carbon are linked to the another 4 carbon atom. Means here is a 1 carbon atoms are attached to the another 4 carbon atom. Then those carbon atom are also attached to the another 4 carbon atom. This is the chain or link formation. This is the diamond form. Now in that diamond, this is the diamond, and diamond in which the sp3 hybridization will be take place in that diamond. Now diamond is a tetrahedral in structure. Then diamond, it has a carbon and carbon bond. We know that I write here a structure, it's a carbon and carbon bond are attached to each other, and those carbon bond, its a distance is a 154 picometer. Here is a pm means picometer, it's a distance of carbon and carbon bond, means it's a bond length. Now it has a hardest natures of substance. We know that the diamonds, it's a hard in nature. Then it's a high boiling point because it's a very hardest substance. That's why its a boiling point is melting point is also high, and its a melting point is 3930 degrees centigrade. It's very high melting points of the diamond. It's a diamond and its melting point is 3930 degrees centigrade. This is the diamond. I will repeat again. The diamond, it has a sp3 hybridization. Then in that diamond, it's a tetrahedral in structure. Then it's a carbon-carbon bond. It has a 154 picometer. It's a carbon-carbon bond length. Then it's a high melting point, and in that high melting point, its a melting point is 3930 degrees centigrade. Now we will discuss in the uses of diamond. We know that the diamond is most useful in nature. It's a use in a jewelry. Now making a jewelry, the diamonds is mostly useful. Then for cutting a glass and drilling a tools in which the diamond is used. Then for making a dies, for a drawing thin wire from the metal, means in which the metals are formed, and then making a dies or drawing thin wire. It's a diamond in nature. Now this is the diamond, and diamond is an allotropy of carbon, and it's most important thing in the allotropies. Now the second point is graphite. We also seen or we also hearing the graphite. Graphite, it's a layer of carbon and carbon atom. Means 1 carbon atoms are attached to the another carbon atom, then another carbon atom is also attached, and here is a layer of carbon atom, and in that layer of carbon atom, the another layer are also attached to first layer of carbon atom. This is the carbon layer of atom. In that graphite, here is a 2-dimensional sheet is a carbon atom, means 1 layer of carbon atom, and it's a below also 1 layers of carbon atom. This is the means 2-dimensional sheet of carbon atom. In that graphite, its a structure is a hexagonal in nature. Means the graphite structure is a hexagonal in manner. Now in which the sp2 hybridization is take place, and here is a sp2 hybrid orbital are formed in that graphite allotropy. Now in that also similar, we know that the carbon-carbon bonds are connected and joined to each other, and then this bond, its a bond length is 141.5 picometer. Means graphite in which the carbon-carbon bond length is a 141.5, means 141.5 picometer is the bond length. Now it's in which the weak van der Waals force are applied in that graphite allotropy. Okay, now allotropy of graphite is a two-dimensional carbon layer sheet. First layer and below the another second layer. This is also carbon atoms layer. Now its a structure is a hexagonal in nature. Then its a sp2 hybrid orbitals are take place in that graphite, and its a carbon-carbon bond length is a 141.5 picometer, and in which the van der Waals force is a apply, and it's a weak force, and it's a 335 picometer in size. This is make of graphite is a soft and splurry in form. Now the graphite is completed. Now the next is allotropies of carbon is a fluorines. It's a fluorines is a C60 is a examples of fluorines. Means here is a carbon 60 compounds are occurs in the fluorines. Carbon 60 compound is a like a football structure. Now it has a shape is a square ball. Means football are same shape like a C16 of a fluorine. Now in that fluorine, it's a electric arc in a struck between the graphite electrode. Means in which the electrical arc and struck in which the graphite electrodes are used in that fluorine allotropy. Now in that fluorine allotropy in which the inert gas are or atmospheric pressure is take place, in that atmosphere it's argon and helium. Means here is a argon and heliums are used in that fluorines. Now the C16 has a shape, it's a cooler ball, and it's called as a Buckminster of fluorine. It's called as a Buckminster of fluorine. Fluorine is a third allotropy of carbon allotropy. It's a third types, and it's an example of a carbon 60. It's an example of fluorine. Now in which the electrical arc in a struck between the graphite electrode, and in which the inert atmospheric pressure is used as the argon and helium atom, and its C16 has a shape of square ball and called as it's a Buckminsters of fluorine. This is the third types of the allotropies of the carbon. Now the next allotropies of carbon is a carbon nanotube, and graphene is fourth types of the carbon nanotube is, this is the cylindrical in shape, and these carbon nanotubes and graphene we will discuss in a next lecture. In this lecture only we will discuss in the allotropies of carbon, in which the first one is a diamond, fluorine and graphite. Then next two we will discuss in a next lecture. Thank you.